Hello, welcome back. This is episode number 9 in the CKong series where I reproduce the arcade version of Donkey Kong using C11 and SDL2. In this episode, we are going to implement the how high can you get state in the state machine, and there's a couple of parts to this. So I'm actually going to run the game, because we're going to use the built-in tile editor to do a lot of this. And so first we need to, the tile map starts off with zeros, so we need to clear this, and there's an option in the menu to fill the map with a given tile and palette. So we're going to clear it that way. Then we are going to go, let's go here. And we're going to copy the header here. Okay. Then we're going to put the message. Unfortunately, our message here is going to overlap with the footer a bit, but that's okay. It's about right there. I'm just, actually, I think it might be one over. So then I'm going to, I got to pick a different palette, because we want our text to be white. And the fourth entry in the palette is usually the text color. So we pick that, and we're going to go into ASCII mode. How high can you get? Now the question mark is, we're going to have to do that by hand. So we're going to go back into tile mode, and we're going to pick the question mark, which is all the way down here. And there's a space in the arcade. Yeah, I think I'm off a little bit. So this is, the question mark is lined up with the life. So let's do this. Insert, about like that. Yeah, and that looks about right. I'm just eyeballing the arcade here. I've got a YouTube video on my other monitor. So then I had done this previously, and drawing this out is kind of a pain. So we're gonna just copy it. And so there's one tile vertically, and that monkey is 4 tiles high. So 1, 2, 3, 4. Is that right? That's, yeah, it's about right. I think I'm off. I'm off by 1. So unfortunately, the copy buffer, it doesn't remember. Let's do this. Paste it. There we go. That's much closer. And of course, the quickest way is just go into ASCII mode and space over tiles you don't want. And then, so right here, we're going to manually pick the meter, lowercase m, and then the 25 is using these smaller numbers. Okay, just like that. And that looks pretty close. So there's a whole bunch of these, And the way they did it is the little monkey just kind of stacks on top of the previous. So what I'm going to do is I'm just going to copy this now, and just going to go, there's no space between them. So 1, 2, 3, 4. Oops, I was off by 1. So he's only 3 tiles high. That's okay. So we'll copy this again. Go down 1, paste, there we go. Okay, so it's 3 up. So it's 4 across, I think, and 3 high. Yeah. And then, so let's say 1, 2, 3, 4, 5. I think that goes up 6 of these. So, oops, in the wrong mode. Let's get back into tile mode. One, two, three. Three. We'll just go all the way up, even if we don't use them. 2, 3. Okay. And then the measurements go up by, the heights go up by 25 meters each time. So, yep, we're already on 5. Then this is 0. Then this would be 75. And then this is 100. Oops. And then this would be 125, or no, sorry. Yeah, no, 125, that's right. So, and then this is 150. And 150, I don't think the game actually ever uses. I think it goes up to 125, and that's it. But that's okay. I mean, we just fill it up, and that's it. That's that tile map. So let's save that. And now, programmatically, how does this work? Well, we start at the bottom, right? And the monkeys above it, the levels above it, we don't see those. So what we're going to do is we're going to write a function that, given a level and a stage, so there's Donkey Kong actually has two, like it was one of the first games that had this kind of level stage pattern to it. And based on the level and the stage is how many of these we're going to show. So it'll kind of work backwards, and the higher the level, the more we'll reveal of these. And the way we'll do it is well, first, when we enter this state, we will disable all the tiles that are in this range, right? This one can always, everything below that can always be enabled because we always see it. So, and then based on, yeah, I guess the way to describe it is when we enter this state, based on the level and the stage you're on, we will hide the appropriate number of these, and then what's left is what you should be seeing. So let's save that again. And this is index number 4. So before I forget, the way that I'm version controlling the tile map is the application produces the file. And so I'm copying it to the assets folder whenever I make a change that I would like to version control. Okay, so now in the code. First, let's go here. Yeah, so on the level structure, yeah, I don't think we need to do anything there. Player, you're on a level and you're on a stage. So and we never display the stage on the screen. It's just an internal value that we track. All right, so in the state machine, we're going to go to how high, enter. And then we need to do one other thing. In tile map, we need to add a new constant here for our how high. Okay, so just to do the really simple tile map, how high. Let's just set the tile map just to assert that when we transition to this state, we can in fact get a tile map from the file, and it's the right one. Then we'll add the code to adjust it appropriately. I need to go to insert coin, and all right, if we press the X key, so if joystick button pressed, start. Okay, so technically we shouldn't be able to press start, and context machine credits is greater than 0. So for credits, let's do key pressed, STL scan code 1. And actually, I believe the arcade tracks coins distinctly. So let's make this an array. and then we'll change this. So here we will say if context machine credits sub 0 is less than 255, then we can increment it. And actually, what I'm going to do, to kind of make things a little bit shorter. Okay, and then the credit, so go to machine. Why did I? Okay, so let's fix this. It's fun stuff. I should have just, yeah, let's do this. Make it format and then variadic. Temporarily. Okay, so then we need to refactor this a little bit. So let's go steal our var arg. And what we're going to do is create a buffer here. Since we're printing to the display, we can make this buffer pretty small, right? We know that there are only 32 tiles horizontally, so we don't need to make this buffer exceptionally large. So actually, let's do 33, because we want to be able to go to null, and so buffer. Okay. Now, why did I do all that? Well, so now I don't have to do this sprnf stuff separate, right? I can just say %06d and just pass the parameters, and it's much cleaner. There you go. Okay. See, it gets rid of that formatting code, and we don't need it spread all over the place. Okay, so what was I going to do? Oh yeah. So here I want to. This is going to be like 31, 31 or 30. Right, because it's YX palette, and we know we want, yeah, palette at 1, that sounds about right. This is going to be 2 characters, and we want to just do machine credits 0 plus machine credits 1. And then I'm going to check real quick what the arcade actually does here. And then this is going to do a pop state, and then we're going to push S state, or S, how high, because we're gonna test the how high state. There, that's what I want. Okay. So let's just, oops, doop, doop. Oh, and this is important. I have a machine DAT already, but I just changed the structure. This is not, like there's no serialization here. This is literally copying the binary image from memory to disk and then copying it back in, which is super simple and it works. And honestly, for a lot of things, that's really all you need. The downside, of course, is like there's no versioning here. So if I were to run that, at best, it would just corrupt memory. At worst, it would crash. And we don't want it to do either of those. Okay, so there's our coins, and it actually needs to build, this is 30, 29, 28, 27, so it's like 27. And then the palette is different. So let's look at, it's not palette 1. So we go into the tile editor, and the palette is 3. So let's change this to 3. All right, so now the credit value is actually going to show what is recorded in the machine. So if I hit 1, right, okay, so credits go up if I hit 2. Now, let's really briefly here, I'm going to just run MAME, and because my memory's horrible and I can never remember all these little details. Okay, so if I hit 5, if I hit 6, 5, 4, no, so it's only, okay, so if we have a credit, it looks like there's only, MAME is not, yeah, it's really glitchy for some reason. Okay, so yeah, I'm going to leave them both in there because typically there are 2 coin slots. For now, this is good enough because we're not really working on this. We just want it to be close. So, and really what should happen is we should transition to the credit state, but we'll worry about that later. Yeah, credit update, right? Because this technically, this is the insert coin state's kind of like an attract state. And this state just shows that screen for a timer, goes to the demo for a timer, goes to the title screen and then comes back. And then technically, if we, insert a coin, then we should, of course, increment the credit and then transition to this screen, because now you have credit in the machine, and now the machine is in the state of, okay, you can play, right? We don't go back to the attract mode. We just sit there and wait until the player decides to play, because money has been tendered, and you can't just ignore that, right? The operator would have to reset the game, which is why you can walk up to coin. You could back in the day, you could walk up to coin ops and someone put money in and then didn't play for whatever reason. It's still sitting there waiting for you to play. So anyhow, yeah, we'll come back to that. All right, so now I got to remember what I mapped this to. I don't remember what key I mapped this to. Return. Okay, that works. Okay. So, here we go. Let's run it. The other thing I'm going to do here is I'm going to write a config, or just like a config file out, so I can reopen the window where it last was, so I don't have to keep dragging it around. That's kind of more of a operational issue. Now, interestingly, you'll note there are 3 credits here. The reason that we persist the credit information is because technically in the machine, again, unless you have an operator go in and I wouldn't want to say void, but you basically you reset the credit counter, that information's persisted, because as far as the machine's concerned, someone paid. So if machine lost power, right, let's say you put quarters in the machine, lost power comes back on, the machine goes back into a mode where you can play because there are pending credits, because again, back in the day, popular arcade, if you had lost power and the operator had to run around to every single machine and give, manual credit, that's a pain in the rear. So the machine would actually remember. Now, again, the game here is not, this should show that we should go immediately to the credit state and, you can start play, but we'll get to that. So start is enter, right? Boom. Okay. So we've got the right tile map. It looks okay. Now let's write the code that's going to display the right thing based on what stage we're in. So how high? Okay. So we want to do this. We want to enter the how high state. We want to set the tile map. But we also want to update the flags here. So I'm going to run this again, and I'm going to go into the tile map editor. And okay, so this is 18 hex by 7 to so what is this? 7 to 13 hex. Right, so that's the low row, and then the high row is just going to be, it's like 4, 5. All right, so this goes up to 5. Okay, now let's write the code that'll just disable those rows. So we'll start at 5 until 18, which is what, 24? So let's do a decimal. And we need to get the block for a given location. Oh, yeah, actually, and so this is going to be in X is 7, so 16, 19. Okay. Now we want to get the block. So the video tile function takes a Y and an X location and it returns a pointer to, oops. I got base code on the mind. Returns a pointer to that control block from the control table. And all we want to do here is change the flags to remove the enabled. And we also at the same time have to set the changed flag because we want to change the background. We actually want to update it. So we need to do that. And that's it, right? So that should disable down to the 25 meter. So let's see, we got that right. So we still have credit. Almost. We were off. I'm off by 1. Yep, it's the name of my game. Off by 1. All right. There we go. Okay, so that's what it would look like at the beginning. Now let's adjust this. So we know that how are we going to do this? Because it's a combination of level and stage. Because really what I would like to do is just create a mapping table. Because the X is always going to be the same, right? The columns that we're adjusting, it's this that changes. And really it's the start value, right? That's going to increase that's going to be higher by 3 until it's literally the same. So let's I don't want to do this. So it's actually, so this is 25. So what we would have to do, because the level goes up to 22 on the actual hardware, and it crashes because there's a bug. But the game, the level stage cycle resets after 4. So it's 1 through 4, but there are the stages in between. So one thing we could do is we could just linearize it. We could take the level and add the stage to it, and that, so it's level 1, stage 1, which of course we would 0 base. So it's 0, level 1, stage 2, that would be 1. And I believe that's still 25 meters. Then level 2, stage 1, that would be 25. Then the so then it would be 22, I believe. So let me bring this over here. Let's go. Right, so, oops. That's not what I wanted. Okay, so level 1, stage 1. And then okay, level 1, stage 2. Okay, so it does go to 50. So level 1, stage 1, level 1, stage 2. And okay, and I think that's it for level 1. Now we're going to go to level 2, and it resets. And then, so yeah, level 2 is then the original girders, the bouncy thing, and then the rivets, and then okay. Oh, I missed. Yeah, let's watch the end of that one. Okay, yeah. Okay, so it's every level, the number of stages is the level number plus 1, except for the 4th level, I think. which has slightly different behavior. So for the first level, it's 0 and 50, or I'm sorry, 25 and 50. For the second level, it's 25, 50, and 75. And then that pattern would just repeat. So let's just use that as a starting point. And let's just change this to be S level to row. And it's going to be context machine, no, context player level plus context player stage. And that's nasty. So let's do this. All right. So those default to 0, so we should just get the 25 meters, which was what we were getting before. Yes. Now let's go and change player. I guess we don't even have to do that. We could do it here. Let's do that. So let's do this. Player T player. And again, I'm doing this because it makes it shorter. And hopefully in a debug build it won't. But in an optimized build, the compiler is smart enough to get rid of dupes and things. Okay, so we have the player. Let's change, we're on level 1. So let's change the stage to, so we're at 0, now we're at 1. This should be 50 meters. Ooh, almost. So this should be 21. 21, 18. All right, try that again. Yep, okay, very good. Now, obviously I'm not updating the level thing in the top header yet. We'll get to that. So this is what I wanted to accomplish in this episode. So what do we got? We laid out the tile map. We added a little bit of code to the insert credit screen so we could at least put some coins in and get credits and then hit the start button. There's more that needs to happen there, but it was enough to bootstrap us to this point. And then in the how high state, we set the background to the tile map we created. The tile map has all the possibilities in it. So what we need to do is erase the ones or disable the ones, the rows that we don't care about. So we have a loop here. So we look up so we start at the top, which is row 5, and we work our way down, disabling rows until we reach the row that represents what that should be for the level that we're on. Level here is kind of a combination of level and stage. So I created this array. I don't know how much I like this array, but it's simple and it works. So this is literally the Y row on the tile map that we want to erase to. So when we're starting out, level 1, stage 1. So this is level 1, stage 1. We want to erase all the way down to the 25 meter because the 25 meter always shows. For level 1, stage 2, we want to show the 50 meter and the 25 meters. We're going to race down to row 21. For level 2, stage 1, right? So level 1 has 2 stages. Level 2 has 3 stages. Level 3 has 4 stages. Level 4, I believe, has 4, plus it repeats one of them. I'll have to go through the game to be sure. But these are the Y coordinate, the Y row. So we get that from the array, and we just get that by taking the level number and the stage number, 0 based, of course, and adding them together to get an index into this array. Let's see. Yeah, and so then level 3 would be a repeat with a stage 4. So this would be 14. Is that right? Yeah, I think that's right. And then level 4, let's just say it's this for now. But that's basically what it looks like. And we can test that, right? We could say player level 3, stage 2, let's do stage 3. So that should be 75 meters. Ooh, not quite. So let's see. 0, 1, 2, 3, 4. It should be. Oh, right. 0, 1, 2. I'm in the wrong one. So 0, 1, 2. So 2 plus 2. Yeah, that's not going to work, is it? Because they're different. All right, there's got to be a better way to do this. So let's tidy this up. Oops. Okay, so what we're going to do is we're going to have row, we're going to have elevation, and level, stage. Yeah, let's do it this way. It works. So level 1, stage 1, elevation. Well, we don't need the elevation. We just need the row. Okay. Row. And level 1, stage 2 is 18. Oh. Helps if you have the right data type. So 25, this should be 25, 21, should 25, 21, 18. Okay. Nope. All right. So we got level and stage and then the row. So we just need a helper function. And this can just take a const player pointer and since we don't have many levels, I'll make that a signed value, and this is just the marker. So there we go. There we go. Oops. Okay, so we're going to match on level and stage because then it allows the thing to be non-uniform. So we just have a helper function, takes in the player pointer, loops through all the elevations, looks to match the player's level and stage. The struct is one based, so it's easier to kind of, or I should say the field values are one based, so it's kind of easier to reason about. And so then here, we're just going to get a const level elevation t, and we're just going to pass in the player, and then this is going to be e row, right? And then I guess technically, right, maybe there's some garbage. We don't get a valid one back. Okay, yeah, that's better. Okay, so then if we're at level 2, stage 2, we should see 50 meters. That's what we should see. And we include, blah. If we increase the stage to 3, we should see 75 meters. Okay, so go. Ooh, okay. So I'm off. So, So 25 minus 3, right, because we're going to do level 2, stage 2. Is then that should be 19, right? Oh crap. Okay. Yeah, this is the problem. I'm doing this wrong. Because this is 0 based. Okay. This is the problem. Eventually, I'll get my head around it. Here we go. Okay, so the structure is 1 based. This is not. Do I want it? Yeah. Okay. Let's just assume that this is always, it's 1 based. So let's go back then to, where was it? Was it player? Yeah, it's player. So let's just make level and stage. They're just 1 base because they're not, at this point then, they're not indexing into anything. We're going through this function to look stuff up. And I think that's just going to make it easier to work with in general. Okay, so those are 1 base. We're comparing 1 base to 1 based. So 2 and 2 should be 50. Let's see what we got. Yeah, okay. So now stage 3, level 2, should be 75. Almost. This has to be 17. Somehow I ended up off on those. Okay. Boom. Okay. Now let's go to level 4 or level 3, stage 4. So level 3, stage 4 is going to get us to 100 meters. Ooh, 125. Okay. Level 3, stage 3. That's 75. Okay. Should be 30. Oh, yeah, I copied the wrong way. I'm so silly. Okay, there we go. Well, we know level 4, stage 5 will work. Okay, then this should be 100. Yep. And then level 4, stage 5 should be 125. The 150, I don't think the game actually ever uses, but we'll leave it in there. It doesn't hurt anything. Okay, that looks good. I mean, that's exactly what this should do. Now, there's one last piece to this state. This state plays a little song, right? It plays the... So let's go back just a bit. I'm going to say that that is... It's about 3 seconds. So we get 60 frames per second. So let's do static UNT. How 5 frames. So I said about 3 seconds. Yeah, we need to come back to this. Right, so really what we probably ultimately maybe need is one large-ish structure that has all this information in one spot. So maybe we'll refactor this as we get down the road, because we can use that same structure to evaluate where to go next. But the game is frame locked to 60 frames a second, and it hits that pretty good. Sometimes it goes a bit above, a bit below, but in general, we're right around 60 frames a second. So we know that every 60 frames, 1 second has elapsed, more or less. So we set the number of frames to count down. And of course, we need to do that actually every time we come into the state. We need to reset that. So this is going to show just long enough for the, excuse me, for the little tune to play, and then it's going to move on to the next state. Okay. So for now, we'll do game screen 2 because that's the one I have drawn. Okay, so 2, 3. Ooh, kaboom. What do we got here? Format is null. Oh, that's because I never fixed these. Oof. That is one downside to variadic functions here. Oh yeah. Still, it ends up being cleaner, just unfortunately the compiler doesn't catch stuff quite as well as I'd like. 1, 1000, 2, 1000, 3, 1000. Still no. Oh, because I didn't do this one either. Oh yeah, because this has to be, this is the help message, and it's, darn it. This is an example of where we're drawing a string, but it's a string of values that draw different tiles, not ASCII. So I have to kind of build it as a byte array manually. 1 1000, 2 1000, 3 1000. Yeah, there you go. All right. Yeah, our frame rate is like hovering right at 60. Now, the sprites and everything obviously are all in the wrong spot because, you know, I haven't conditioned anything to this particular layout. But and our blink is off and our high score is off because where I put them on in the tile map editor isn't where I had them when I had them hard coded. So yeah, I might have to revisit that, but that's fairly minor. Not too worried about that. Doesn't quite climb right. Okay, so that's good. This is what I was hoping to get done. So let's review that and talk about next steps. So the CKong dat file is just a binary file that has the tile map information in it. I copy it into a source directory. It gets version controlled. Ultimately, I probably will add a feature where I can export this as some kind of text format. Maybe it'll be C source code, maybe it'll be YAML or something, I don't know. I'll figure out something so it's a little bit nicer to work with in version control than binary data. And then the textual version, you know, you can run it through the program and it'll create a new dat file for you. And then vice versa, you can, when you save it, it'll save in development mode, it'll save the binary and the text. I don't know, we'll see. So in video, I changed video BG stir to take a format string and a variadic list of arguments so that we don't have to have the formatting code kind of strewn all over the place. We know we only have 32 tiles across, so we know we can't format massively large strings. So we have a 33 character buffer. We go through the var arg list and we format the string into our buffer. And then I just updated the code to generate our tiles in the background map based on that buffer. In tile map, I added a enum value for tile map how high because we now implemented that in the actual tile map data. In player, I added a new field for stage. So Donkey Kong it's a level and it's a stage. Stage is not actually shown on the screen, but it's kind of there. So internally, it's convenient for us to think of things as level and stage, so we know exactly what to do in the state machine. Level and stage, we're going to treat those as one based, just like we're doing with lives. And we set those to 1 and 1 to start. Also, I had to refactor all the uses of video BG stir. So the string and the arguments go to the end, and yeah, so I had to update all those. In machine, I changed the machine structure slightly. So there's credits, and I have 2 slots for credits. This is probably getting a little bit too close to the machine itself, but technically you have two different coin activation mechanisms, and this allows us to treat those separately. So if we have two buttons that we're going to press that represent those coin triggers, we can put the coins in the right bucket. Now we actually end up adding those together, but to track them independently, I made that an array. And then in the init, I make sure that the credit array is initialized properly. And then I had to update calls to video BG stir. In level, same thing, had to update calls to video BG stir. And then finally, in state machine, this is where the bulk of the code changes were today. In the insert coin update state, we grab the machine pointer, and if we hit the 1 key or the 2 key, we update the appropriate credit slot. If we hit the start button, which is the return key, we go to the how high state. Now this is not exactly correct, but we're going to incrementally change these as we implement new functionality. So we'll be revisiting this stuff. And then now this state actually dynamically just updates the credit amount on the tile map. So whatever credits we actually have in the machine, that's what gets displayed right now. And let's see. Okay. In game screen 1, I changed the tile map that we're using because I don't have the initial girder level laid out yet. I have the one where you pull the little rivets out. So I just set the screen to that. And then for the how high state, so this is all the new stuff. So I created a little struct. It has a level and a stage and a row in it. Now I'm actually thinking that this probably needs to move to the level module. And that includes a little helper function. So we'll do that next. And this struct needs to be enhanced, right? Because there's a bunch of little things about the level and stage that we need to know. Like, we need to know what the row is to display the how high information, but we also need to know what the next, or what game state that represents, and possibly some other information. So I can see this getting refactored, but for now, for the level and the stage, this row is starting from row 5 to this number. That's the number of rows we're going to mark as disabled so that that how high information doesn't appear. And then we have a helper function that takes a player pointer. We loop through our structure here, and we're looking for the level and stage for the elevation struct that matches the player's level and stage. And we find that, we return a pointer to it. In the how high enter, so this is when we come into that state, we set the tile map to the one that's in the tile map in memory data we got from the file. So this has all the different how highs in it, right? From 25 meters to 150 meters. We set the number of frames that this state's going to be active. We grab the player. Temporarily, I'm setting the level and stage so we can see what that looks like. We grab the elevation, right, for that player. And then we loop over those rows and the columns, and we mark them as disabled. That hides them. And then in the update, we just, as long as we have a frame counter that's above 0, we decrement it. Once we hit 0, we leave this state and we go to the next state. And this is where I was talking about, we need to probably move this level structure into the level module. We need to kind of extend it a little bit, because this is where we would say, oh, hey, given this player, tell me what the next state should be, right? Because the player has the level and stage on it, and we need to know where to go. Right now I have it hard coded, but this is obviously not the way it should be long term. Okay, so that's it. So let's make sure that's okay. So this is episode 9. How high can you get? All right. That'll do it. In the next episode, we will move on to implementing other parts of the state machine, and we'll, slowly get everything tied together and working. So I will see you then. Bye.